everybody, welcome to my little video on how to use TraceWrangler. And I'm going to keep this relatively short, relatively sweet. TraceWrangler is a really powerful tool. Let's first of all just install it so we can then talk about it. So what you want to do is open up a web browser like I have, go to, or just do a Google search for TraceWrangler. If you can type it right. There we go. And first thing that pops up here should be TraceWrangler Packet Capture Toolkit. I'm going to click on that. This lands us at the home page. So TraceWrangler.com is the correct place. Now that we're there, we can see there's a little introduction. TraceWrangler is a network capture file toolkit running on Windows. You can run it on Linux using Wine. I'm not going to do that, but I have used it there. Supports PCAP and PCAP-NG, which is the standard file format used by Wireshark. And what TraceWrangler basically does is, and its primary use case here, is to sanitize and make PCAP files anonymous by changing things. And we'll take a little look at this and we'll run a couple of examples so you can see what that means. This removes and replaces sensitive data. So these are some of the features I know you can all read, so you can see that. There's a screenshot of what it looks like once it's up and running. And this is where you can download it. So the last post here looks like March 24th. It's mid-May, mid-COVID where I am. So let's see, 0.68 is the latest build. I'm going to go ahead and click on the 64-bit version for Windows. I'm obviously running Windows. And that should download. It's about 20 megabytes, not very long at all. And we have the zip file. Okay, so I'm going to click on that and the zip file opens. So I'm in my downloads path, but you can see this has opened the zip file. And let's go to the README and see what is said here. So it kind of repeats all of that stuff. There's the website, and let's see, it runs on most Windows systems. It's really simple to install. It says copy the executable anywhere you like and just start it. Okay, well, let's do that. So I'm going to close that. I'm going to copy all of these. So Control A, Control C, and then on my desktop, I am going to create over here a new folder, and we'll call it TraceWrangler. There we go. And then open this folder and right click and then paste everything in here. So that's just going to copy everything over from the extracted view that I had. There we go. So it is good. I'll go ahead and close these. I'm actually going to close this for now, and let's open up this and we can just run TraceWrangler right here. There's the application. So let's run it and see if it starts. Windows is warning me, and I'm not going to worry about that. I'm going to say run anyway. And there we go. So TraceWrangler has started up. Again, I have version 068, build 949. And we can see there are a couple of big buttons here, add files, add directory. So you can drop your packet captures into this area and then you can do things with them. So we're going to do that primary use case where we anonymize. Let's go grab a file. Okay, so let's test out the basic features of TraceWrangler by simply doing the number one reason you would use TraceWrangler, which is to anonymize a packet capture. All right, so I'm going to go back to my file manager here, and I'm just going to navigate very quickly to where I have, okay. So right here, I have a packet called toCapture.pcap. And what I want to do is I want to drag and drop this file into TraceWrangler. Let's bring this to the foreground. So there we go. We have dropped it in here. You can see if I click on the file, TraceWrangler gives us a whole bunch of information about this file, all sorts of great statistics about this file. Now, you'll see in the list, and you can, by the way, have multiple files in here, and you can assign different tasks that you want TraceWrangler to run on these different files. Now, we're going to just do a simple anonymization, but let's assign a task to this, and then we will look at the anonymization options. Actually, let's click here first. So this is the task called anonymization, and you can see here that there are a whole bunch of options that you can set. I'm leaving everything as default so that you can just see what the default behavior is. You see there's a payload section here, and by default TraceWrangler is going to remove all the unknown layers, okay, and it's going to cut those away. Then there's a pcap ng, and this is going to sanitize certain things like the interface header blocks, name resolution blocks. Again, it will just replace all of this information in its process. You can then go to layer 2. You can mess with 802.11 if you have that. Now we don't have that in this capture. We have Ethernet options here. We can recalculate CRCs if we're replacing MAC addresses. Again, not worried about this. I'm just going to let it run its default. It's going to randomly assign MAC addresses. There's a VLAN option. We don't have any VLAN traffic, but once again, you can replace VLAN tags and then, of course, recalculate things. Also with tunnels. Then in layer 3, we have IPv4 options. This is going to replace the IP address. It's going to automatically do this. You can replace with a known set of addresses if you pick them. I'm just going to leave it do its default thing, as I said. Same with IPv6, ICMPv4, ICMPv6. TCP, okay, fine. Here, I know we have some TCP traffic in this. This is not going to be modified, okay? Basically, it's just going to go ahead and leave that alone. It will recalculate CRC if it's needed, but we could replace TCP ports by list, same with UDP, also DHCP. This is going to actually sanitize and replace any DHCP, and then RTPS, same thing. All right, everything here I'm just leaving as default, but you get an idea that you can modify this task. The output of the task is going to place the new packet capture that's been anonymized in the same directory as the packet capture where the source came from. So right in this same directory back here, we will see a new file being created once TraceWrangler has done its thing. And then let's see, any settings we need to know about? Not really. Okay, that's all fine. All right, so I'm going to go ahead and say okay to that. That's fine. So basically this device here, we are going to anonymize because I selected anonymize. Now, normally you would add the task down here, but that's fine. It's been set up. The task is pending. So let's go ahead and run the task. And you will see there'll be a little progress bar up here. So what is going on here is this is being treated like a database of packets, and it's managing this database and all the relationships. This is just a super cool program, and the author, Jasper Bonnerwitz, is absolutely a brilliant guy. You can find lots of information about him. I will place a link, of course, to this information about him and about where I got this tool in the video information below this video. All right, so it has completed the task. All right, very good. And if we look back here, I'll just move this off to the side, you can see that a _anon file has been created. Now it's a lot smaller than the other one because a lot of this stuff has been removed, okay? But let's go open both of these now in Wireshark just to see what this process looks like. So I'm going to go ahead and close this. I'm going to open up the toCapture.pcapng file. So this was the original file. You can see it's 38,592 packets total. Starts with TCP, etc. So we'll leave this here. And then let's open up the toCapture anonymized version. You have to be careful with Wireshark and opening up multiple versions, by the way, in Windows anyway. Sometimes Wireshark gives us a hassle here, but hopefully we'll be able to see the difference, and we'll jump sort of back and forth between the two. Let me resize this a little bit, and maybe we can get a better side-by-side view. All right, so again, the original file here is called 2capture.pcapng. We can see this, we can see the colorization and so forth. And already we see it's quite different over here. You can see that we have different source and destination addresses. This is actually pretty amazing that we would have these type of time frames. I can always tell when something's been anonymized because I would expect this to be on a local area network. I would expect everybody to be in the same subnet because they're on the same LAN. I mean, that's how you get less than a millisecond response time, and here, right, this makes more sense over here. But anyway, of course we could have fixed that, right, with the anonymization settings, not taking anything away from the program. Now, they are also what appear to be completely different colors and everything. So let's take a look at why they're different. So I'm going to select here packet number 2, which in the original capture, Wireshark is saying is an NBSS file, and we can see it's NetBIOS session service right there. And it has data. And back over here, packet number 2, it is the same packet, but we do not have the NetBIOS information. You can see that's been all stripped off of the packet capture. So the number of packets is the same. However, the size of the file has gone way down, and basically anything after TCP has been lost. And you can see this very quickly. I can just scroll all the way down here. I don't think I see any. Yeah, I don't see anything at layer 5 or above. Everything is just stripped off after the TCP header. So this sort of takes us back to the old TCP dump days where that sort of thing would happen. But this is good. This is a great way to now use this file if there's an example of issues at layers 2, 3, or 4. This is a great way to anonymize the data. I'm protecting any data. Everything seems to be fine. Let's see, let's take a look at some of the other issues and compare them side by side. So I'm clicking on the little dot here, which is the expert info. It's a quick way to call up this expert info. So this is the report we're getting from the 2capture.pcapng. Let's do the same thing here and compare them a little bit side by side. So you can see that the packet comments are gone. We also have a warning here, and let's take a look at these warnings. 1700, 17196, some unseen segment. So something doesn't seem right here after the anonymization. So we might be introducing a false positive issue here. I'm not going to go into looking at this. The notes appear to be the same. The chats do not quite appear to be the same. Why? Because we're missing the higher order stuff. Like you don't see HTTP or SSDP. You'll notice those are missing. So that sort of makes sense. Okay. So overall, not too bad, right? Not too bad. All right, let's close these out and take a look at another view to compare these, which is I always like to go to statistics and conversations. And this is with the original file. All right, we see 21 TCP conversations. Now let's look at it here. Statistics, conversations. I have to bring this over as well. So, okay, so the conversation numbers are all the same. No difference between the two files. Of course, the addresses are significantly different, but all right, so let's filter for one of these. We'll just do like a nice little 8-packet filter. Right click, apply as a filter, selected A to B. So now I'm going to close this. We're looking at this particular conversation. Let's do the same conversation over here. I believe, oh, I didn't track it. So let's go back and do that again. And I'll make sure I select the same exact one. So conversation. So we're going to select the first one that is 8 packets right there. Okay, right click, apply as a filter, selected A to B. All right, close that out. And then back over here, we're going to do the first one that is 8 packets right there. Right click, apply as a filter, selected A to B. Okay, perfect. We now have that filter. And let's see, source and destinations have been anonymized. Okay, they look different. But the conversation looks to be good. all of the port numbers, FINAC. The only thing that I see missing here is we see right here that there was some sort of push bit, and then we see the FINAC, but we do not see, because everything is erased after TCP, we really do not see the GET, and we do not see this HTTP response. So we're seeing over here 8 packets. Over here, we're seeing 8 packets, but they're not labeled correctly. So this is the GET, and that is the HTTP traffic, which began the end of it because it was just basically one response. So TCP has been happily maintained. It looks fine, but we're now missing the HTTP. And if we're good with that, like I said, this is fine. And we can also change those settings to include that stuff so it would look more equal. And maybe that would get rid of some of these false positives as well. So I'm very happy. I think this is really wonderful. It's done a great job of handling this basic packet capture and anonymizing it, like I said. So very happy with this. I'm going to go ahead and close Wireshark, and let's try something else. Now let's try to use Wireshark and TraceWrangler together to do something I always struggle with, and TraceWrangler really provides a wonderful solution to, which is ring buffer files. Okay, so let's start Wireshark here, and I'm going to set up a ring buffer, so we'll see the files come out here. If you're not familiar with what a ring buffer is, I would encourage you to look into this. I'll put links to several things where you can learn more about this, but basically what we're going to do is we're going to go to Capture and Options. We're going to select the Wi-Fi interface, which is the interface that I'm running on here, and I am going to say output, and I'm going to say ring buffer with, let's make 10 files. Okay, we're going to create a new file. Let's do it after every, I don't know, say 15 seconds. Now, I'm not going to make you sit through this. We will fast forward the video, so we'll hurry up and do the capture, but you'll get an idea of what this does. And so every 15 seconds, we're going to create a new file. We're going to go for a certain amount of time. I'll just let it run until we've got a nice set of 15 at some point. I'll let it ring around so we get to see that part. But anyway, now I want to browse, and I want to go to the desktop, and what we will do is we will put these files on the desktop and we will call them ring test. Okay, and I'm going to save this. That gives us the complete path. It's very important to put the right path in here for it to work properly. All right. Okay, very good. So I'm going to go ahead and start this, and you will start to see the files appear here, but it will be sped up, so no worries there. All right, here we go. Okay. So I'm now going to stop the capture. I think we've got a good idea of what has been going on here. So I don't know if you notice this, but the ring buffer basically sets up these files. I'll just click on this, and the word ring test is the way I configured it, and you can see it's this one is 003, this one is 004, this one is 005, etc., etc. And what happened when we got to the 10th one, which I believe was this one, yep, that's number 10, 11 basically overwrote number 1, and then 12 overwrote number 2. So you can see this will just continue forever if I let it run forever, and we never run out of disk space. That's the idea of a ring buffer. The problem here, if you're managing this from a day-to-day basis, is now I want an easy way to combine all of these. Okay. So right now we've got 11 right here. 12 is sitting here just right where I stopped it. It says 12. So I'm going to say File, Save As, and I'm going to call it, well, I need to go to the desktop, and I'm going to call it Ring test underscore 0012. All right, and that will put it right there. Okay, so very good. I'm going to close Wireshark. My job with Wireshark is done. At this point, I want to go ahead and open up TraceWrangler, and I want to add all of these capture files. So what I'm going to do is I'm going to select them all, minus the actual TraceWrangler folder. I'll unselect that. And then I'm going to drag these. Actually, let me make sure these are selected as well. Yep, they are. And drag these over into the drop area. Okay, so it looks like it captured some other stuff as well, and I didn't mean to do that. So I'm going to say no to this and let Wireshark process all of those captures. So good, all of the captures are now processed here, okay, and no task has been assigned. So I want to select them all. So I'm going to select the first one and then say Control A. And then what I want to do is down here, I want to do an instant merge. And it'll give me the options to concatenate, merge them by interface name. So if you've got actually captures from lots of other places, you got to be careful when you're doing that sort of thing. But let's just say, okay, we'll take all the defaults and let it do its thing. So what we should get is a capture file with everything that has been merged. Okay, so it says task pending. Let's run the task. And I think it's actually done already. Although it says task pending, I see a file that was created called merged file. So let's go ahead and open this up. And now we should have one nice big long file. Remember, each one of these was 15 seconds. So as we go down to about 15 seconds, right here, right there is where we would have picked up with the next file, and so forth and so on. And now you can see they're all beautifully merged into one file. Now you have to be careful with this, of course, because this could be an enormous file and you might run out of memory and so forth. But that's where TraceWrangler comes in to help you with carving and parsing big, huge files as well. So hope that was a good second application of TraceWrangler. Let's move on. All right. In this last piece, what we're going to do is basically the opposite of what we did when we merged files. And this is another very important, really powerful thing of TraceWrangler. Now you can imagine if you had this enormous capture file, or you had merged a bunch of files into this enormous capture file, and now what you want to do is you want to go in and you want to sort of parse or carve out of that a particular conversation. This is something that TraceWrangler does really well. So let's use our merged file. So there it is. I'm going to drag this over into TraceWrangler. And then what I'm going to do, select the file. You can see this is the set of ring buffer test files that we created. And you can see that the file comments were added by TraceWrangler when we created that merged file. So now what we want to do is the exact opposite. So what we want to do is we want to now find a particular conversation in here and extract it out, because that conversation may have existed across multiple of those merged files. All right, so let's click on Extract from Files. And you can see there are flow filters, metadata, and then output. So the flow filters here are expressions, or we can add filters if you will. Okay, so you could certainly add a filter, you could look one up and so forth. I'm not going to actually do that. The other option is to find metadata. I'm not going to do that either. And then there's where you want this to go. And what we'll do is we'll place our output in the same directory as the source file. So it'll put it here on our desktop. Okay, and you can specify other options here. Again, I won't cover all of that. So let's say, okay, so now what we want to do is we want to run that. This is all appearing on my other desktop. It's almost done, and it's a tremendous, tremendous amount of work that has just occurred. So let's move these over so you can see what just happened. So I'm going to bring these over to this desktop, and they're all going to appear behind. But you can see on my desktop here that what has happened is that literally, because I put no rules in here, almost every single conversation was extracted. I can just double click on one of these and I can open up Wireshark and take a look at that particular conversation. In this case, it's between 192.168.1.53 and 192.168.1.38. So here we go. Wireshark has opened up. And in this case, you can see it's just two very simple packets that were a DNS query. Okay. So that's kind of cool that it does all of that. But at the same time, it's a tad ugly, right? We'd like to control this a little bit better. So what I'm going to do is I'm going to select all of these files, and I'm actually going to delete them. And we'll just move all those to the trash. So is there a better way to do this? And the answer is yes. So we'll look at that next. Okay, now here is a better way, I think, of doing what we just did. Certainly we saw all of those files being created, but you can focus TraceWrangler into just carving out a particular conversation. And the way that you do this is you go to Tools and then Communications Details. Now, to me, this should say maybe conversation details. I don't want to pick a bone with the author. He's a smart guy. But anyway, you select communications details and you're going to get a screen that looks like this. And I'll make it just a little bit bigger so we can see. Okay, so here what has happened is that we have a set of tabs. These represent the various protocols and the number of conversations at those protocol levels. Now this is very similar to the conversations capability of Wireshark itself. So we see, for example, there are 17, if I click on this, 17 TCP conversations. Now what's nice about this is that now I can actually select one of these and I can simply filter for this and extract just this particular conversation. So let's pick one here that's a fairly good number of packets. So we'll take this one right here, which is 14 packets. So now that I have selected that, what I can do is right click on here and say extract to a single file containing all rows. Okay, so I'm going to do that, and it pops up with the dialog of where we want to extract this. Now I'm going to move this to my desktop. There we go. Oh, I need to give it a file name. So let's say extraction 1 and click on save. And then I need to look for it over here because it came up on my other screen. So there it is. So there's extraction 1. Now I can open this in Wireshark and I should see 14 packets. There we go, 14 packets displayed. And this is that TCP conversation. And you can see it was TLS and so forth. Now, this conversation is not a complete conversation, clearly, because we don't see the three-way handshake. However, these packets occurred across this particular set of merged files, and now this has all been extracted out. So you can see there's actually quite a big time difference here. So this happened between multiple of those merged files. So pretty cool. And you can do this for any of the conversations. Beware, though, that you could end up with some issues depending on when the conversation started to when the conversation ended. You may not get the entire conversation. This all depends. Again, it's not really TraceWrangler's job to do any of the study of the packet capture like Wireshark would do. Instead, it's trying to help us to find these things. Let's see if we can find a more complete one. We'll do it one more time. So I'm going to select this last one here in kind of hopes that this does something. So let's see, right click, and we will extract to a single file. Again, we have to sort of go through the same process. I need to, oh, it's already defaulted to my desktop. Excellent. And we'll call this extraction 2. And save it and I'll bring it over here. There it is, extraction number 2. Let's open this and see. Yeah, much better. Okay, so we've got a sin, ac. Yeah, this is looking a little bit better. So really cool, right? That we can do this and carve out of this big merge file or some giant set of capture files. We can find these conversations, we can extract them, and then we can study them in Wireshark. So this is a very powerful capability of TraceWrangler to reach into a very large packet capture and give us all of this information. Again, where you do this is with the tools and then communications details, and then you pick the tab of the conversation that hopefully will make the best sense for what you're trying to narrow down to. If you can't find it at the upper layers, try going down a layer and finding your conversation down here. Again, watch out for errors, watch out for the same thing we ran through where you may not get the whole conversation, or TraceWrangler might get fooled into putting different pieces of separate conversations together depending on what you have in your capture file. Again, you'll find that 99% of the time this is going to work exactly as expected. So I think that that makes a great overview of what TraceWrangler is about. And Jasper, you made an absolutely fantastic tool here. It's always a work in progress. There are always going to be issues. I encourage you to look at the documentation for TraceWrangler. It's a very complete set of documentation. I'll just pull this up here and show you the website to where that is. There we go. So if you go to tracewrangler.com/documentation, you will land at the documentation pages. It's sort of like the man pages. And you can go through here, take a look at all of the information. And there is information on how to reach Jasper, how to send him an email, and I'm sure he will get back to you as quickly as he can. All right, so I hope you enjoyed this video on TraceWrangler, especially those of you who are my Wireshark people. I hope you enjoyed this. I hope you find use for TraceWrangler like I do, and I'll see you again in another video. Thanks for watching.